Now let's take a look at an absolute value problem where we can use our strategy of getting rid of our absolute value signs, and we can apply it in more of a systematic way to get rid of our absolute value signs and then use that to make just normal algebraic equations, which we can then solve to answer our absolute value equation. I believe this is the first problem we've seen that uses absolute value equations instead of inequalities. And so just glancing at our question here, some things you might notice our absolute value expressions seem to be getting a little bit more complicated than in the previous questions. So for example, we have algebraic expressions on each side of our equation here. However, we still only have one absolute value expression, and we only have one variable within our absolute value signs, which means if we go back to the categorizations here, this would still fall under the simple category, which means I should be able to do these algebraically. And so that's what we will be looking at here. So our question says, is x equal to 13? Literally no information given, just a question. And so statement 1 says the absolute value of 4x plus 11 is equal to 5x minus 2. So now our goal here is to get rid of our absolute value signs. And so even though we have an expression under our absolute value signs, it's no different. I don't want to use x again because we have an x here. Than if we just had like absolute value of a, where in this case a just happens to be equal to 4x plus 11, because we said once we have the absolute value of a, there's only two things this could be equal to. When a is greater than 0, absolute value is equal to a. And then when a is less than 0, absolute value of a is equal to negative a. Maybe I should say here, this is when a is greater than or equal to 0. And so here, it is no different. And so we just have two scenarios, two possibilities for what 4x plus 11 could be. 4x plus 11 it's either greater than or equal to 0, or it's less than 0. And so these two scenarios, they count for 100%. Even though there are infinite values for what 4x plus 11 could be, these two scenarios account for all of them. And so we said in this case here, when 4x plus 11 is greater than or equal to 0, absolute value of 4x plus 11 is just equal to itself. This is the case of absolute value of 5 being equal to 5. So absolute value of 4x plus 11 is just equal to 4x plus 11. And in this case here, when 4x plus 11 is less than 0, that is the case of absolute value of negative 5 being equal to 5. And so in this case, absolute value of 4x plus 11, if we get rid of our absolute value sign, is just equal to, we got to remember, we got to reverse the whole thing because we're multiplying the whole thing by negative 1. So negative 4x minus. And so then we can use these two scenarios to just solve for x by plugging in these guys for absolute value of 4x plus 11. So we're only plugging in for the left side. The right side is not changing at all. So in this case, we have, instead of absolute value of 4x plus 11 being equal to 5x minus 2, we have just 4x plus 11 is equal to 5x minus 2. Here, negative 4x minus 11 is equal to 5x minus 2. Now we just need to solve for x. So in this case, subtract 4x from each side. We get x over here. And add 2 to each side, and we should get x is equal to 13. That is one possibility, and this is a yes to our question. Is x equal to 13? Now we just need to do the same thing here. And so you might be thinking, oh, we're on track. We're headed for insufficient because we're going to get two values for x here. But hold on to that thought. We'll see if that is in fact true. And so if we solve for x here, add 4x to each side, we get 9x is equal to negative 9. X is equal to negative 1. And indeed, looks like it should be insufficient because this is a yes, this is a no to our question. And so we think it's insufficient, but not so fast because we are not done yet. Because when we have these absolute value equations, where we get rid of our absolute value sign and made two algebraic equations out of it, there is one last step that you always have to do. And you might have been scratching your head a bit at the beginning when we did this. So what you have to do is once you get a value here, once you solve for x, you then have to plug it back in to this inequality here. Because what we did is we made these designations. We said this here is the scenario where 4x plus 11 is greater than or equal to 0, because that is when absolute value of 4x plus 11 is equal to 4x plus 11. And here, same thing. We said this is the scenario where 4x plus 11 is less than 0, because that is the case where absolute value of 4x plus 11 is equal to negative 4x minus 11. And so therefore, we are the ones that made this designation, and we just sort of made it arbitrarily. Therefore, when we solve for x, we have to make sure this is in fact true. Because if it's not in fact true, then we couldn't make that designation originally. And so here in this case, plugging in 13 for x, 4 times 13 plus 11 is definitely greater than or equal to 0. So this answer is legit. What about here? Plugging in negative 1, 4 times negative 1 plus 11, that is not less than 0. So this here is an erroneous answer choice. And in fact, we only have one answer choice. X is equal to 13. And therefore, this answer is actually sufficient. And that is actually a good thing, because we can now eliminate 3 of our answer choices. Now, if you were thrown off a bit by that last step, we now have another chance to go through it again in the second statement, which is basically we're going to use the same process. So this says absolute value of 2x minus 5 is equal to x plus 8. The same thing. We want to get rid of our absolute value sign. There are only 2 possibilities. What absolute value of 2x minus 5 could be equal to? 2x minus 5 is greater than or equal to 0. The absolute value of 2x minus 5 is just equal to itself. Then when 2x minus 5 is less than 0, you just have to multiply it by negative 1. So absolute value of 2x minus 5 in this case is equal to negative 2x plus 5. So now, just plugging these values in for our absolute value expression, we get 2x minus 5 is equal to x plus 8. Again, it's only the left side that is changing. The right side, the side without the absolute value bars, does not change. And then over here, negative 2x plus 5 is equal to x plus 8. So solving for x, we get x is equal to 13. It looks like we are headed for a similar equation as the first statement. Over here, we get, if we add 2x to each side, we get what? So 3x, subtract 8 from each side is equal to negative 3. X is equal to negative 1. It looks like we have the same situation. Does that mean we shouldn't test these answer choices? Absolutely not. you cannot skip that last step. And so do not jump to saying this is also sufficient. We still need to test this. So 2 times 13 minus 5, that is greater than or equal to 0. So this works. What about here? X is equal to negative 1. So 2 times negative 1 minus 5 is equal to negative 7, which is less than 0. So this side also works. Now, what does that mean? That means the statement, the second statement, is actually insufficient because we get 2 legitimate possibilities for x. X could be 13 or x could be negative 1. Whereas in the first statement, x equals negative 1 was erroneous. And so statement 2 is insufficient for A is the answer. And one last note just about why statement 2 is insufficient, and this is a good data sufficiency lesson that is sort of universal to data sufficiency. Why is it insufficient? It's not just because we have 2 different values for x. Let's say we had a different situation where we solved and we got, x could be 4 here and x could be negative 1 here. Well, if this happened, our answer would have actually still been sufficient as opposed to insufficient, because here x equals to 4, that is a no to our question, because our question is asking, is x equal to 13? And x equals negative 1 would also be a no to our question. And so even though we have 2 different values for x, they both give us a no to our question. In order to be insufficient, we need 1 no and 1 yes. And that is what we have here, because x equals 13 is a yes. X equals negative 1 is a no. So the reason this is insufficient, it's not just because we have 2 different values for x, but because one of them is equal to 13, one of them is not equal to 13. And so that is what you want to be keeping in mind with data sufficiency. So this is a good absolute value lesson, but also a good data sufficiency lesson. And so in the next few videos, we will start doing some of the more complicated absolute value questions with multiple variables or multiple absolute value expressions. And we'll talk about testing numbers a bit.